Welcome back. Thanks for joining. This is Rashid. So previous video I gave introduction of an overview of the entire training that I'm starting here, and this is second video. So we'll get a little bit closer to the main topic now. All right. So anyway, with me, my son Shazal is sitting. So the goal is that I'll be teaching him as well. It's nice to have somebody sitting with you that you're looking into and teaching. So it's a big help for me. And he might ask questions here and there, although he's a man of very few words. So, but let's see how that goes. I don't know if our schedule will always align, but we'll try our best to kind of come together and where he is learning, I'm teaching, and I'm recording my screen, so you guys will be learning that too. So I think it gives a little bit different feeling to me that I have somebody with me. Anyway, all right. So our goal is we are going to design, implement, verify, and do physical design of a 32-bit RISC-V processor. Okay, so I pick RISC-V processor because we don't need to get a license from anybody. This is an open source architecture. They gave us, and I will explain all these things. They gave us what kind of instructions it follows. We just can use them. We can create hardware. We can create our own IP. We can sell that IP. We can use that IP in our product. So that's why I picked this one. Okay, but another key reason I was first thinking of maybe do a dedicated hardware. What I really want you guys to, and want you, Shazad, to learn is how to create a hardware to solve a particular problem. That's really the goal here. And sometimes when we the teachers teach, it's hard for students to make a connection from that theory to the actual application, right? So I'm starting with a different way here. So I am starting what I'm calling a just-in-time fundamentals. Even though Shazal, I have, we started looking into a lot of gates and combination and all that. But I think what I'm doing is, one approach is I teach all of you just all the fundamentals again, or I can point you, okay, logic design, start with the gate and all that. Those fundamentals are super important, and I'm going to cover those. But the way I'm going to cover those is I'm going to start with a processor level, and wherever we need to dive into something fundamental, then I will give you some videos, and today I will give you some videos. Hey, watch this one. If there is not there, I'm going to explain that. But instead of going through all the fundamental first and then build that, I'm going to do a new approach. I don't know. Let's see how that goes. But I hope this gives you some different way of looking into it. Make it a little bit more interesting. I think that's really my intention here. Okay, so just in time fundamentals, we will use for this design, for all these stages, we will use open source tools, whatever free is available. So it will be great for students. So everything is free except this this playlist, which is a membership for my YouTube, but it's very reasonable for students all over the world. Okay, so it's US, Europe, $2.99 a month, and in India, I think the last time I checked was 59 Indian rupees a month. So I really want to make it very reasonable for everybody. Okay, so a blueprint, the thing that we have in front of us is, and in the next 5-6 months, you will become expert on RISC-V. Okay, so it's really the RISC-V instruction set architecture. In a similar way, there's an Intel instruction set architecture, which is called x86. Any other? You remember? ARM, yeah. Right? They have them. But we used to have a MIPS one. I previously studied MIPS one, but MIPS is kind of, I don't know, going away, got into RISC and all that. So I thought, okay, for a lot of open source tools are available for this one, so let's stay with RISC-V. Okay, the book I'm going to follow is this book. This is a very good book. Okay, I have a non-RISC-V edition. I'm going to get a RISC-V edition on it. But this book covers not just RISC-V. It kind of builds all the digital design that I have built in my previous videos. And I have used this book as a reference for a lot of digital design, logic design concepts as well. So strongly recommend you guys have a PDF version, soft version, or buy a book. Really recommend buying this, and really thanks to these folks for creating this wonderful book. And it takes you pretty step by step. And where I'm gonna start, not from the chapter 1, I'm gonna start with chapter 6, which is the architecture, I think. Okay, so that's where I'm gonna start, and then I'm gonna go into different topics. But I will not. I might give you a reference to the book, but main goal will be give you the reference of my other videos. Okay, all right. So this is our book for the course. So this RISC-V is a 32-bit machine. When it's a 32-bit processor, the one we are going to study. Actually, that is RISC. What is it called? RISC-32I integer. That is the very basic one. It has different version. Okay, floating point. There is some extension as well, but the one maybe it's called RV actually. I tend to forget things. It's RV32I. That is the fundamental one, the basic one, and we will look into its architecture. It's on their website as well. We can load what kind of specs. So specs come from there. Now, what are those specs? What they tell, what they don't tell. We will talk about that. So don't worry about it if you don't understand that. But the key thing is a 32-bit machine. What when I said it's a 32-bit machine, what does that mean? That processor. I mean, processor everybody knows because all of you guys use gaming, processor, CPU, and all that. So you know that. It's how many bits in address bus?
32.
32. How many bits in data bus? 32. And it also, what I didn't mention, it also has, so we're talking about the CPU. This, when it gives address to memory, sorry, this is the address, it's a 32-bit. Now when there is a 32-bit lines, how many unique combination we can have when there are 32 bits? By the way, the notation we typically use, I'm not going to put 32 wires here. I'm going to put one wire, and I'm going to do this dash, tilted dash, and 32-bit. Mean there are 32-bit lines. Okay, so if there are 32-bit lines, then each one can be 0, 1, 0, 1, 0, or 1. How many unique combination you can have? From 0 to?
2 to the 32nd power?
Yes, from 0 to 2 raised to power 32 minus 1. These many unique numbers it can have. Or overall, these will be 2 raised to power 32. And that is fundamental thing. If you have 2 bits, 2 lines, and each one can have 0, 1, 0, 1. How many combination we can have? 0, 0, 0, 1, 1, 0, 1, 1. So these are 4, 2 bits to the power 4. And the number is from 0 to, what's this one, last one?
4.
No.
Yeah, 3.
3, right? So total 4, but start with 0, then it goes to 3. So we say it goes from 0 to 2 raised to power 2 minus 1. All right. So that means using these 32 bits address here, how many unique unique location of memory we can access?
2 to the 32nd power minus 1.
Yeah, 2 raised to power 32 total locations.
Yeah.
It will start from 0. So if I give you this memory, will start somewhere 0, 1 to all the way, when all those 32 bits are 1, 1, 1.
Yeah.
Okay. Now, here what I gave you that, okay, we typically, if I start putting all 0, 1s in one, it will be too much. Right? So typical notation that we use is hexadecimal too. For example, I'll put F. F mean all ones. So this is where you need to learn, and this is, I'm going to give you, and also to Shazal, that, okay, the fundamental concepts that you need to learn is binary system. Because we will talk about 0, 1, 0, 1, right? So it's very important that you know, and this will be 32-bit memory, 32 memory location, the address is 32-bit, and within each memory there's a 32-bit data. So we are assuming I have a memory which I have all these locations that are possible with 32-bit. I have enough memory, it has these many locations. Each location has a 32-bit stored here. Right?
Yeah.
So that means this concept, guys, is fundamental for you. And also, Shazal, you need to watch this. So this is the logic design series I'm going to refer. I think you have done already quite a few there, right? So topic number 8 is where when I was starting into arithmetic logic unit, I was started talking about binary system. So this is, guys, for your homework, topic 8, topic 9, the binary, not completely topic 9. Let's not go into addition, subtraction yet, but if you can watch it, this will cover addition and subtraction, two's complement and all that. So let's get that out of the way. You guys watch this one and I will ask you some question next time. Okay, same for you. Okay, all right, so that's what I'm going to do, keep taking you back to the fundamental videos. So those, watch those one. But coming back here, really, if you think that, where is my video? Sorry, I'm going backwards. Overall, our system is a CPU, which is 32-bit. It has address, can give to memory, and it can 32-bit data that it can write into each location of the memory. It is also capable of reading 32-bit data at any one time from the memory. Then using CPU, whatever is in the memory, some instruction there, and the sequence of instruction when we execute, it can do some operations. And when operations are done, it can write them back into memory. Or it can send some signal to the IOs. What are the example of IOs on a computer?
Like a
keyboard
mouse.
For input, mouse for input, anything for output. Screen is for output. What kind of ports we use? HDMI, VGA we can use, and some other ports, USB. You can connect some USB devices, mouse, keyboard, or other thing.
Yeah.
Right, USB-C, some of the latest one. Right. So these are called controllers. We will have controller which gonna communicate with the real world. So for between real world and CPU, you need to have some mechanism to kind of send and receive information from the real world. This is called the I/O. So we can say, okay, we have a USB controller, we have this or that port controller, right? So so those will be the one we might, I don't know, we will do it or not, but my goal is to build a chip that covers these three, really. Okay, so but we will heavy focus on this one. We reuse, this will be reuse. All right. Okay, I think we have finished this one, and yeah, let's finish this one. In the next video, I gave a little bit idea of what is a compiler, what is an assembler, what is instruction format, and all that. A little bit concept on that. But I will pretty much go into the chapter 6 and go one by one. I really want to follow an already well-written book or well-written curriculum, but the explanation might be a little bit different from me. All right, that's it. Let's stop this video, and we will meet soon with the next topic. All right, see you. Bye.